Hi everyone. So we're going to talk about here is differentiation topic again. So if you can, you may pause the video here if you want to read the question and take some time to understand it. Okay. So now let's talk about this question here. Okay, in this question here is talking about an inverted cone with a base of 5 centimeters and a height of 12 centimeters. Okay, and the water is leaking at the tip of the cone here. Okay, so now let's just talk about what is given. What are the informations given? The water is leaking out of the tip with a rate of 4 centimeter cube per second. So that means 4 centimeter cube per second. When they say rate, okay, you need to understand that is dV over dt. Okay, and then they're asking you the rate of change of depth. That means they're asking you the height here. So that means what is the rate of change of height against time? Okay, so what they're asking you this. Okay, now when they give you the height is 3 centimeters. Now you need to understand, first of all, you need to recall what's the volume of a cone. The volume of a cone, if you could remember, is 1 over 3 pi r square h. Okay, so now if you notice, there is two different unknowns here. Our main aim here is to try to convert this h here into r, because that is something we can work with. Okay, why? Sorry, to convert the r here in terms of h. Okay, why? Because we are talking with a subject of h here, not r. So how do we convert? Okay, let's just look at this cone. I'm going to do the 2D section here. A 2D section meaning, okay, what we see from the side view is a cone, okay, which I cut into half is a triangle. Okay, now originally the radius is 5 centimeters here and the height is 12. Now, what happens here is the water has gone down to a depth of, okay, h with a radius of an unknown value. Okay, so in terms of an idea here, we can call upon the ratio. Okay, so with radius has changed from 5 to r. Okay, let's just compare, is directly proportional or equals to the height to 12. So r is as equals to 5h, or 5, the height times 5 over 12. Okay, so we got our r. So now with that understanding, we can convert our volume here. It's 1 over 3 pi r, okay, which is 5h over 12 square times h, okay, which is equals to 1 over 3 pi, okay, 25h square over 144h, which is equals to, if you compute directly everything, you'll get 25, okay, 25 pi h cube over 432. Okay, so we already got our volume, okay, in terms of h. Okay, the pi is constant, so you don't have to worry about it. Now, we need to understand here is, okay, when we got our volume, okay, 25 pi h cube over 432 here, okay, we need to understand that is we need to get the rate of change. Okay, when you talk about rate of change earlier here, if you notice, we need dH dt, we have dV dt. So what we can understand here is we have dV dt, okay, which is equals to dV times something, okay, dV over something, times something which has dt at the bottom, which we could recall we have dH here. So dH here, and then, so hence we can differentiate this one to get dV dH. So with this, we can understand that what is dV dH? Okay, so dV dH here is as very simple as you can see. You just have to differentiate the h, which is equals to 3 times with 25 pi, okay, h square over 432. But then you also need to remember, okay, the h here is given as 3 from the earlier perspective that they talk about here. The height is 3 centimeters. So what we get from here is this 3 will be inside here. So 25 pi 3 square over 432. Just punch in the calculators. Okay, just punch in the calculator, and you guys can see that the value you will get is 25 pi over 144. Okay, so we solved our dVdh. Our dH dt here, what do we get? Sorry, we have our dV dt here, 4 centimeters. So dV dt here is 4 centimeter cube. dV dH is 25 pi over 144 times dH over dt. So as we can see here, dH, sorry, my bad. Okay, dH over dt is equals to 4 divided by 25 pi over 144. And again, if you punch in your calculator, you'll get a value of 64 pi over, sorry, the pi is at the bottom, 64 over 25 pi. If you can, but then you notice something, okay, you need to notice something here is that this guy here is leaking, okay, leaking out. Hence, this one here is negative. So, if you notice as well, you need to add a negative here, okay? So the final answer will have a negative. So when you put in the value of the pi together, you have negative 0.8148, okay? And this is centimeter per second, okay? So this is our rate of change, okay? Why? Because the height is dropping by this rate per second, okay, for the cone. So please take note, when the height is increasing, it's positive, and height is decreasing, it's negative. So please take note of the negative. I purposely omitted out the negative so that you could highlight it at the very end so that you'll understand that the negative means the water is leaking out and the positive means the water is being absorbed in. So I hope you all understand, and see you all next week for more questions and more understanding of other chapters and other questions. If you have more questions, please do share with me, and I would be glad to help to solve it for you. Thank you for watching. See you all next week.